All right, in this lesson, we're going to be talking about exponential expressions. These are expressions, not equations, that have exponents in them. This is based on Blitzer's Intermediate Algebra for college students. All right, so first thing you need to realize is what is an exponent and why do we use them? Well, it's actually good that we use exponents because exponents are really a shortcut way of writing something over and over and over again. For example, the base 6 cubed, which is the exponent, means that I multiplied 6 times itself 3 times. So, as you can see, when you get into some of these, I would not want to write some of these over and over and over 5 or 6 or 7 or 8 times, or sometimes even more. We have really large exponents in math and science, like to the 23rd. If you've ever heard of a mole, 6.02 times 10 to the 23rd power. I don't want to write that many zeros out there or that many bases. So what we want to do is use the shortcut method. So this is the expanded form, or the long form, and then this is the shorthand way of writing it. Notice that if you have a negative in front of something raised to the exponent, whatever is the base is what's being raised to that power. If it's not in parentheses, it's not part of the power. It's not being raised. So in this case, we're saying what's the negative of 5 squared? Well, that means what's the negative of 5 times 5? Well, the negative of 5 times 5 is 25. Here, I'm saying negative 5 multiplied twice. Negative 5 times negative 5. That's positive 25. So the exponent only applies to the base. The negative is not part of what you're being multiplied over and over and over again unless it's in parentheses. So let's do a few examples. So 3 squared is the same thing as 3 times 3, which is 9. The 2 tells me that I'm multiplying 3 2 times. The 4 tells me I'm going to do this 4 times. Negative 3 times negative 3 times negative 3 times negative 3. And sometimes it helps to put it all in parentheses so we can keep track of what we're doing. And that ends up being a positive 81. So you might ask why. Well, negative 3 times negative 3 is positive 9 because a negative times a negative is a positive. Negative 3 times negative 3 is also positive 9. Positive 9 times positive 9 is positive 81. Aha! This negative is not part of the exponent. So basically this is saying, what is the negative of 7 times 7? Well, that's negative 49. The negative is not being raised to a power, so you don't have to worry about that. 3 tens in a row. 10 times 10 times 10. And if you remember your tricks of multiplying things times 10, whatever the exponent is, that's how many zeros you're going to have. For example, if you had 10 to the 21st power, you would have 21 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay? That's what you would do. All right. 1 to the 7 power means I have 7 ones being multiplied. Whoops. By them. Oh, my goodness. Getting excited with my ones. Okay. 1, 2, 3, 4, 5, 6, 7. 1 times anything is just that number, so we're going to end up with 1 anyway. All right, let's look over here. So let's combine like terms, just like we talked about before. Well, an x square and an x square is kind of like a thing, okay? So an x square is something that's being squared. We don't know what it is. So these two are the same. So like if you think of x squares as rulers, I've got 3 rulers plus 5 more rulers. So I have 8 rulers. We don't square the 3. We don't square the 5. They're not part of what's being squared. Only the x's were squared. Okay? 7x squares minus 4x squares. So again, the x squares can be combined. They're like terms. 7 of them minus 4 of them make 3 of those x squares. 8x squares minus 1x squared. There's an imaginary 1 here. It's just one of them. So 8 minus 1 is 7x squares. Treat it as if they were x's. If you had 3 x's plus 5 x's, that would be 8 x's. They're just not x's. They're squares. All right. Aha. Be careful here. You have a negative 2x squared and a positive 6x squared. Those two can be combined, but they can't be combined with the x's. Those are two different terms. So if I have 6 positives and 2 negatives, I'm going to have more positives than negatives. So I'll have 4x squares. My 4x and my additional x makes a 5x. I can't combine them anymore because x squares and x's are not the same. Now you try. Hopefully your answer looks something like this. Great job. Okay, let's keep going. Now, I got this off the internet. It's not mine. I didn't create it myself. So please excuse my dear Aunt Sally. You probably have heard that before. Be very, very careful using Pemdas, which is order of operations. That means you must do problems in a particular mathematical order. If you do not do them in the same order as every other person in the universe on the planet, you will all get different answers. Life will not be good. So you need to make sure you're following the order of operations. For example, if you take this problem and you said, whatever, math is math, I'm going to do it my way. And you just started going from left to right. And you said, 21 plus 6 is 27. 27 divided by 3 is 9. 9 times 5 is 45. I got this. I don't really need this order of operations thing. But you would be wrong, because the order of operations says that you have to do what's in parentheses first. Then you need to do the exponents. Your multiplication and division have to be done next from left to right. So maybe multiplication's on the left and maybe division's next, or maybe division's on the left and then multiplication. You just do them from left to right. Doesn't have to be multiplication, then division. Same thing with addition, subtraction. You have to do them last, but you need to do them from left to right. Whichever one comes first, left to right. So here we go. So the first thing here is, do I have any parentheses? No. Do I have any exponents? No. Do I have multiplication and division? Ooh, yeah, I have both. Well, guess what? Division is first. It's on the left. So I have to do the division first. 6 divided by 3 is 2. Yes, I start in the middle of the problem. Sounds crazy, but this is what order of operations is. Now I have addition and multiplication. Addition is down here. Multiplication's up there. I have to do multiplication first. 2 times 5 is 10. Then finally I can do the addition, 31. The answer to this problem that we did over here incorrectly is actually 31, not 45. So order of operations will help you get the right answer every time. You have to do them in this order, remembering that these two are really on the same level, left to right, and these two on the same level, left to right. So let's look at our examples here. So PEMDAS, I have no parentheses, no exponents. I do have multiplication, so I'm going to do this first. Okay, now I only have addition and subtraction, so I have to do from left to right. Now all I have is subtraction left, and that is my answer. I have no parentheses. Ooh, I have some exponents. So 7 squared is 49. 4 squared is 16. Okay, as long as my exponents don't involve each other, in other words, there's not something inside of a parentheses raised to a power, also raised to another power or whatever, then I don't need to worry about it. So now I have to choose between multiplication, division, and addition, subtraction. Multiplication and division are first. So here, here's a division. I have to do that before subtraction. Okay, now I have subtraction, multiplication, subtraction. Well, multiplication has to be done next. I have to go from left to right. 49 minus 15 is 34. And then my answer is 32. Okay, so let's do these. Ooh, exponents. 3 squared means 3 times 3, which is 9. This is different. Look, everything in the parentheses is being raised, so I have to work on what's in the parentheses here. The difference is here, only the 3 was squared. Here, all of this is squared, so I need to work on what's inside the parentheses first. And there's your answer. Again, we want to work on what's in parentheses. Now, this parentheses includes parentheses. It includes brackets. It includes the fancy sort of brackets or whatever. What you do is you work on the inside first. If you have multiple sets of parentheses, then you work on the very innermost parentheses first, and then you work your way out. So here I would work with my 6 minus 11. In the meantime, just rewrite everything else that's not changing. If you'll notice, I keep doing that. I still have something inside the parentheses. Now, I can't do anything inside the -5. There's no operation to be done. -5 is -5, so there's no parentheses operation to be done. The parentheses just tells us that my 3 is being multiplied by -5. Okay, so multiplication is here in addition, so I have to do multiplication first. I still have parentheses. Even though this is multiplication and this is addition, I still have to work inside the parentheses before I can start moving outside the parentheses. So this is the same thing as -15 plus 5 is -10. And I can use brackets, that's fine, to keep with the old brackets. And then 4 times -10. There's nothing more to do in here, so I just multiplied. And that would be my answer. All right, you try these bottom ones. Hopefully you got these answers. All right. There's a few more practice problems here. I want you to try them out, and then I'll show you the right answers. My goodness. Okay. All using order of operations. Okay, hopefully you got the right answers. Okay, I will see you next time for section 2.3.